Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutiwa Sos Ugobelawe Mets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 9 on calculus cubic function. It says the graph of h of x is equals to negative x cubed plus ax squared plus bx plus c is sketched below. And then we are given that a and b, which the coordinate is 6:0, are the turning points of h, right? And then we are given that t has coordinates 3:y is a point on h, right? So still lies on the same graph there. The graph of h passes through the origin, as we can see here. It passes through this point here. This is the origin that they're talking about. Now it says, show that a is equals to 12 and b is equals to negative 36, and we are only given 3 marks for that, right? So we must come up with a smart way in which we can answer this for only 3 marks. Now, if you can have a look at the equation, the form of the equation in which we are given, we can see that they try to play tricks on us there, because we normally know that originally a graph of the cubic function would be in this format: ax cubed plus bx squared plus cx and then plus d. So what they did here is that they shifted the a value there, and then they shifted it to the b value, and then they shifted what was supposed to be on the b value to c, and then what was supposed to be d there, now it's c, right? So you can see what they tried to do here, tried to confuse us, but then now we can see their tricks there.
It's about to go down.
So what we are going to do is we're going to consider this to be in this format. So what we are seeing is that we are seeing this in this same format, the original formula: negative x cubed and then plus ax squared plus bx and then plus c. Right. So basically what we have as our C here is what we normally say must be the what? The y-intercept, right? In that position, we know that our constant value is normally the y-intercept. Now, what is the y-intercept of this graph that we are given here? We can see that the y-intercept is just equal to 0. So which means our C value here immediately is equal to what? To 0. Right. But then again, in order to calculate this, we can see that we are already given the a value originally there. And then the a value that we are trying to calculate and the b value is just the b and the c from the original. So what we are going to do is we're going to consult with the intercept method here, right? The root form method, the root form equation. So we're going to write the root form equation, and we are going to say, keep the y and the x. So we're just going to keep this and not substitute this, because remember, we are looking for the equation. So we're not going to substitute in here. We're only going to substitute for a and the roots, a and the intercepts. Now, okay, this is what we're going to have. For our a value, we can see that we are already given negative 1 there. So this is negative 1. We're going to keep the x, and then what is root 1? The first intercept that we are seeing there is 0. Then we're still going to keep this x. The second intercept that we are seeing here, remember we are given the coordinates, this is 6:0. The second intercept that we are seeing there is 6. But where is that third intercept? Remember, if we have something like this, we normally say we have 2 roots that are equal, right? So this is not just one root. Those are 2 roots that are equal. So that means since this point is both an intercept and a turning point, we're just going to use it twice, right? So we're going to have x minus 6 and again x minus 6. So always note that when you have a point that is both an intercept and a turning point, you have to use it twice in the root form equation. So now we have y is equals to negative 1, and then x minus 0 is just going to give us x. Now, if we continue here, we're going to have x multiplied by x, which is x squared, x multiplied by negative 6, that's negative 6x. Negative 6 multiplied by x, again, negative 6x. But negative 6 multiplied by negative 6, that's positive 36. Okay, let's continue. We're now going to have y is equals to negative 1 multiplied by x. We can say this will give us negative x. And then inside the bracket, let's sort this like terms here. So we're going to have x squared minus 12x and then plus 36. Okay, so what do we do now? Let's multiply inside with that negative x. Let's multiply inside with that negative x. So now we have y is equals to negative x cubed. And then negative and negative, that's positive 12x squared. Negative times positive, that's negative 36x. Now remember, what are we supposed to show? We are supposed to show that a is 12 and b is negative 36. Remember, the a that we are talking about is this one, which corresponds to that, which is a coefficient of x squared. Now, what's the value with the coefficient of x squared here? We can see that it is that 12. What value is the coefficient of x here, which is supposed to be negative 36? We can see right there. Right, so that's the b value. So now we've found the a value and the b value, and now we can say, therefore, our a is equals to 12, and then our b is equals to negative 36. So that's how you were supposed to go through that question for only 3 marks. So kind of interesting there, and also the trick that they tried to come up with there. So you need to be very, very careful of the tricks of the examiner.
Please, man.
Okay, so now let's move to 9.2. It says calculate the coordinates of A. Now, as we can see, A is still another stationary point. So point A and B, they did mention that these are the turning points of graph H. So to calculate that, we already know that anything that has to do with calculating the coordinate of a stationary point or the coordinate of a stationary point, you have to do it with the derivative, right? So what we can do now is we go to 9.2, and then we have this equation. Now note that even if you were not able to do 9.1, it doesn't stop you from getting all these other questions, because now what you can say is, okay, 9.1 has already given me that A is 12 and B is negative 36. Remember, when they say show that, that's because it is true. A is 12 and B is negative 36. All they just want you to do is calculate and find those values. So now let's say you couldn't do 9.1. You are now down with 3 marks, but then you can still continue solving the rest of the questions. So by saying negative x cubed, and then where there's A, just replace that given value there, 12x squared. Where there's B, replace that given value, negative 36x, right? Then remember your C value is just 0, so we might just as well leave it like that.
Yeah, well, understand. I'm on another level, my boys.
Okay, now we are trying to calculate the coordinates of A, but we know coordinate of A is a turning point. We calculate the turning point by the derivative, first derivative. So deriving this will be negative 3x squared, remember? Exponent, jump down to multiply coefficient, then subtract 1 from the exponent. Then 2 multiplied by 12 is 24, and then x. Then obviously the derivative of this will just be negative 36, right? But what else do we know? We know that at the stationary points or the turning points, our derivative is always equated to 0. Why? Because we know that at the stationary point, at turning points or stationary point, the gradient is 0. The gradient is equal to 0. Now, why are we relating this to the gradient? Remember that h prime x, the first derivative, is the gradient equation. The first derivative always represents the gradient equation. So h prime x is always telling us about the gradient of the curve at a particular point. So the gradient of the point, the gradient of the curve at this particular point, which are the turning points, is always equal to 0, because the only lines that we can draw there, the only tangent lines that we can draw there are tangent lines that will be horizontal and parallel to the x-axis. So those lines, those gradients there have those tangents meant to say have a gradient of 0 always. So a horizontal line, in mathematics, we know that any horizontal line has a gradient of 0. So because at the stationary points, you can only draw horizontal lines as your tangent, it means the gradient at that point will be equal to 0, which is why every time you are calculating the stationary points or the turning points, you have to equate your first derivative to 0. I hope it makes sense, guys. Then we are going to say h prime x is equals to 0 at turning points. Therefore, now we can have negative 3x squared plus 24x minus 36 being equated to 0. Now, looking at all these numbers, we can see that they are all divisible by 3. So what do we do now? Divide throughout by negative 3. So the dividing by negative 3 is because I want to keep my a value here as a positive, right? So let me just divide by negative 3. Now if I divide here, I'm left with positive x squared. By 24 divided by negative 3, let's see. This is going to give us negative 8x. And then if we do a negative 36 divided by negative 3, this is going to give us positive 12. And then obviously 0 divided by negative 3 is 0. Okay, now at this point, we want to factorize here. So what are the factors of 12? Factors of 12 are 1, 2, 3, 4, 6, and 12. What are two factors of 12? When we multiply them, they're going to give us 12. They're going to give us 12, meant to say. But when we add or subtract them, they're going to give us 8. So it has to be 6 and 2. Definitely 6 and 2. So let's now open two brackets like this, distribute the x. And then since this one is positive, that means we're going to take 6 here and then 2, and then they both should be negative. Is equals to 0. So x is equals to 6 or x is equals to 2. But remember, we are only looking for the coordinates of A. So the 6 here is representing the other stationary point or the other turning point, which is B. So we're just going to discard this one. So we're going to reject this one and only deal with x is equals to 2. As we can see, A is closer to the origin, so it makes sense that its x coordinate would be 2 instead of 6. And also you can see that for 6 we are already, for B we are already given, which is 6. It's that 6. Then remember, we are not done. We still need to calculate the y coordinate. At this point, we've only found the x coordinate. So to calculate the y coordinate, what do we do? Note this. Every time you want to calculate the y coordinate, you have to go back to the original equation. Do not make the mistake of substituting back into the derivative. If you substitute back into the derivative, you're only just going to get 0, right? And it doesn't make sense that the y coordinate of A would be 0 then. So you need to always remember this. After calculating my x coordinate with the first derivative, I need to go back to the original equation to substitute this x coordinate so that I can get the y coordinate. So that means you're going to go back to this equation, and where there is x now, you are replacing by 2. So this is negative and then 2 cube and then plus 12. You have 2 square minus 36, and then here you have 2. Okay, so grab your calculator now. Negative 2, umshinwe ibalo. Negative 2 to the exponent of 3. And then plus 12 bracket 2 square. And then minus 36 and then 2 here. Okay, so this gives us negative 32. Okay, is that correct? Yes. Negative 32. So my A value there is 2 is to negative 32. Right. 9.3, calculate the value of y. This is only just 1 mark. So 1 mark questions should be treated like 1 mark questions. We do not have to sweat there. So basically the only thing that we are supposed to do there, because point T here lies on the curve, we are just supposed to substitute the x coordinate into the original equation and just find our y value. So it simply means for 9.3, all we need to do is say, what is h of x when our x is equals to 3? So we have negative and then 3 cubed. Remember, we are substituting into the original equation. Our a value was already 12. And then 3 here, square. Then this is negative 36 and then multiplied by 2. Oh, no, multiplied by 3. Remember, our x is 3. Yes. Okay, so now let's calculate. So we are having negative 27, right? So that means our t coordinates, or basically our y value, is just negative 27, right? Okay, so that's basically that, guys. That's basically that. That's how you were supposed to calculate. Okay, so 9.4, it says, is the graph of h concave up or concave down at point T? Show all your calculations. Now listen and listen very carefully. You cannot comment on concavity without first finding the x coordinate of the point of inflection. Hence, we can even see that this is 3 marks. We can't just say concave up or concave down based on just looking at that thing, right? We need to be able to calculate the point of inflection. Why is it important that we calculate the point of inflection? Because the point of inflection is where the graph changes concavity, right? Now, given this shape of a graph here, where our a is less than 0, we have a shape like this, right? What you need to understand is that if we can have a point of inflection just somewhere there, let's call this POI for point of inflection. Now, what happens with this type of graph is that from here all the way to that point in blue, this is where the graph is what? Concave up. It reaches the point of inflection, right? Where it's neither concave up or concave down. That's the point where it transitions, changes its concavity. Now, after that point, the graph now becomes what? Concave down. So with a shape whereby a is less than 0, we'll always have our graph starting from being concave up, reaches a point of inflection, and then becomes concave down. So this point here, we are saying it's concave down.
I can see what they're doing, what it's doing. I can see it, I feel it. It's cooking.
Okay, so now what determines this is the point of inflection. So meaning here, let's say our point of inflection, for argument's sake, let's say it was 5. So if we are looking for points whereby our graph is concave up, we would say those points are x less than 5. So meaning all the points before 5. We are looking for points whereby this graph is concave down. These are all the points after x is equals to 5. Right? So this is what we are looking to do with this question here. So 9.4, first thing that we want is our point of inflection, because that's when we can comment on concavity. So how do we calculate the point of inflection? Now, the one way that is familiar with everyone else is to calculate the second derivative. So we have our original equation like this, 12x minus 36 square here, and then 36x. Then obviously we're going to first calculate the first derivative, so which is negative 3x squared, then plus 24x, and then minus 36. But we do not find the point of inflection on the first derivative. We find it on the second derivative. So second derivative is when we derive from the first derivative. So that's negative 6x and then plus 24. But one thing that you need to note is that your second derivative is always equated to 0 at the point of inflection. at the point of inflection. So every time you are trying to calculate the x-coordinate of the point of inflection, note that you equate the second derivative to 0. So, okay, now you have negative 6x plus 24 is equals to 0, which will be negative 6x is equals to negative 24. And then if you divide both sides by negative 6, your x is equals to positive 4, right? So meaning that the point of inflection is just 1 unit away from point T. Remember, we are being asked if the graph is concave up or concave down at point T. But then calculating our point of inflection, we can see our point of inflection is just 1 unit away from what? From point T. So this is our point of inflection there. 4. This is our POI, right? But then we know the nature of this. We know that it has to start from being concave up all the way up until what? The point of inflection. Then it's only after the point of inflection where it becomes what? Concave down. Now, this is just a matter of checking and seeing if your point T appears on the blue or appears on the green. If it appears on the blue, then that means the curve there is still concave up. If it appears on the green, that means at that point, now the curve is concave down. Now we can see that our T value here is still on the blue, right? So we're going to say, therefore, so because our point of inflection, our x-coordinate of the point of inflection is greater than the x-coordinate of T, we are going to say, therefore, a graph of H is at point T, graph of H at point T is concave up. Right, so our conclusion can be that because our x-coordinate of the point of inflection is greater than the x-coordinate of T, we can say the graph of H at point T is concave up. Right, so that's how you were supposed to go through that. Now, there's also another easier way to calculate the point of inflection. Right, so other than just calculating the second derivative or that step there, you can simply say, I already have the coordinates here. So this gave me 2 is to negative 32. And then the B value is just 6 is to 0. Right. Now, you can calculate the point of inflection by just looking at the x coordinates of the turning points. Right. If you can find the median of the x coordinate of the turning point. So point of inflection can also be calculated by saying, let me just say 2 plus 6, only considering the x values, the x coordinate divided by 2. Now, obviously, this will be 8 divided by 2, which will be equals to 4. So this would be the quickest way to calculate that.
We're enjoying ourselves here.
Okay, now, let us now proceed to 9.5. So 9.5 is now saying determine the coordinates of the point of inflection. Note that it is saying the coordinates. Once a question says coordinate, that means it's looking for both the x coordinate and the y coordinate. But then obviously there is no need for us to calculate the x coordinate again because we have already found it from 9.4. Hence we can even see this is 2 marks, right? Meaning at this point, we're only just going to take the x coordinate, substitute back into the original equation so that we can have the y coordinate. Remember, anything that has to do with you having to find the y coordinate, you have to substitute into the original equation, right? So remember, our x coordinate for the point of inflection was 4. So that means all we have to do is say, what is our h of x when x is equals to 4? So into the original equation, where there is x, we put 4. So there we go. And then minus 36 and then 4 here. So obviously in your calculator now, you want to punch that, all of that, and then we get what? Negative 16. So meaning that our coordinates for the point of inflection is 4:-16, right? And that's how you were supposed to solve that question for a total of what? For a total of 12 marks, right? So it was a very pretty interesting question there. So make sure that you come back to this video, watch it as many times as possible, and try to understand the approach that I took into solving all these questions here. But then with all that being said, you know what to do. Share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.